something incredible happened just off the coast. A giant piece of metal was pulled from the ocean. It was not just any piece of metal. This was Starship Booster 13, or B13. Many people thought it was lost forever. It had completed its mission months ago, then it splashed down in the Gulf of Mexico. SpaceX said they would not recover it. They had the data they needed, or so we thought. But then, quietly, a recovery ship went out. It found B13, and it brought the booster back to shore. The return of B13 was a complete surprise. It started a storm of questions online. Why did SpaceX change its mind? What was so important about this particular booster that they had to have it back? The sight of B13 was stunning. It was towed back to Starbase looking like a warrior returning from a great battle. The stainless steel skin was scorched and scarred. You could see the incredible heat it endured during its fiery re-entry. It was a testament to the violence of spaceflight. Yet it was mostly intact. This in itself was a huge victory for SpaceX. To understand why the recovery of B13 was so shocking, we need to look back at its mission. The flight of Starship with Booster 13 was a critical test. It was not the first Starship to fly, not by a long shot. But B13 was special. It was the first booster to test a new, much faster re-entry profile. The idea was to save time and fuel. If SpaceX could bring the booster back to Earth faster, it could fly more missions. More missions mean a faster path to Mars. So, B13 was pushed to the absolute limit. The main goal of the B13 mission was simple: collect data. The booster was covered in thousands of sensors. These sensors measured everything. This data was sent back to Earth in real time during the flight. After the booster did its job and splashed down in the ocean, SpaceX would move on. What also made B13 unique was its heat shield. It used a new generation of thermal protection tiles. The engineers at SpaceX were testing if this new design could handle the extra heat from the faster re-entry. The flight itself looked like a success from the outside. SpaceX declared the test a success. They said they had gathered excellent data. We all assumed B13 was now an artificial reef at the bottom of the Gulf of Mexico. Its story was over. We were all wrong. When the engineers at Starbase finally started talking, the story got interesting. After they took B13 apart, they compared the physical evidence with the telemetry data from the flight. This is where the first surprises started to pop up. The initial data they shared was about the new thermal tiles. The telemetry had shown that some tiles got much hotter than predicted. But the physical tiles themselves told a different story. They were in much better shape than expected. They were scorched, yes, but they were not cracked or eroded as the temperature data suggested they should be. The engineers spent weeks analyzing the recovered tiles in the lab. They cut them open. They put them under microscopes. What they found was that the tiles had changed during re-entry. The extreme heat had caused a chemical reaction on the surface of the tiles. This reaction created a thin, glassy layer. This layer was not part of the original design. It was an unexpected result of the intense heat. This new layer was incredibly effective at reflecting heat away from the booster. It was like the booster had grown its own, more powerful heat shield in the middle of the flight. This discovery was huge. Another key data point came from the booster's structure. The telemetry showed massive vibrations during the final moments of the landing burn. But when they inspected the physical frame of B13, they found very little stress damage. After careful analysis, the team found the answer. The sensors were located near the booster's legs, which were not deployed for the water landing. This was good news. It meant the core of the booster was strong enough to handle even the most aggressive landings. The most shocking discovery from B13 did not come from the tiles or the frame. It came from inside the engine bay. This is the area at the base of the booster where the giant Raptor engines are located. It's honestly one of the most complex and violent parts of the rocket. During re-entry, this area is protected by a large heat shield. When they removed that shield, they found something that made their jaws drop. The area was covered in a strange, thin film of metallic residue. It wasn't soot from the engine exhaust. It was something else entirely. It was something that should not have been there at all. This finding sent a ripple of excitement and, honestly, a bit of confusion through the entire engineering team. Lab analysis of the residue revealed it was a mix of elements from the upper atmosphere and vaporized stainless steel from the booster itself. This was the wild data point. During the super-hot re-entry, the plasma surrounding B13 was not just flowing over the booster, it was chemically reacting with it. Tiny amounts of the booster's steel skin were being stripped away, atom by atom. Then, as the booster cooled down in the final seconds before landing, this metallic vapor condensed. It settled as a thin film all over the engine bay. No one had ever predicted this would happen. This phenomenon, now called ablative condensation, was a game-changer. It explained why the engine bay, which should have been incredibly hot, was actually cooler than expected. The process of the steel vaporizing and then condensing had absorbed a huge amount of thermal energy. In a way, the booster was sweating to cool itself down. It was using its own skin as a sacrificial, heat-absorbing layer. This was a completely new type of thermal management system. It was one that SpaceX had invented by accident. It was a perfect example of how real-world testing can reveal things that even the most advanced computer simulations will miss. The discoveries from B13 are not just interesting facts for scientists. They have a direct impact on the future of the Starship program. For people who follow space exploration, this is honestly a big deal. The finding about the heat tiles creating their own glassy layer is huge. It gives SpaceX confidence to push the boosters even harder. They now know there's a hidden safety margin built into the tiles. This means they can attempt even faster and more aggressive re-entry profiles. This could shorten the turnaround time between flights. Instead of waiting weeks to refurbish a booster, they might be able to do it in days. This is the key to making a rocket fleet that can fly as often as an airline. The data about the vibrations is also critically important. Knowing that the booster's core structure is stronger than they thought is a massive relief. It means the design is solid. They can focus on fixing the smaller issues, like the rattling landing legs, without having to redesign the whole booster. This saves a lot of time and money. It allows them to move faster toward their goal of routine orbital flights. For anyone hoping to one day see cities on Mars, this kind of progress is exactly what you want to see. It shows that SpaceX is solving the hard engineering problems one by one. The wildest data point, the ablative condensation, might be the most significant of all. It opens up a whole new way of thinking about heat shields. SpaceX can now try to control this effect. They might even be able to enhance it. Perhaps they can use a specific steel alloy that vaporizes more easily to improve the cooling effect. This could lead to lighter and more efficient boosters. A lighter booster can lift a heavier Starship. A heavier Starship can carry more people, more cargo, and more fuel. This is how you make a trip to Mars practical. It all comes down to making the system as efficient as possible. B13 provided a major, unexpected clue on how to do that. The story of B13 is a perfect example of SpaceX's philosophy. They build, they fly, they learn, and they repeat. They're not afraid to push their machines to the breaking point. Sometimes the machines do break, but even in failure, they gather priceless data. The recovery and analysis of Booster 13 shows this process in action. They had a successful flight, but they knew there was more to learn. So they went the extra mile to recover the hardware. That decision has now paid off in a huge way. The lessons learned from this single booster will make every future Starship better, safer, and more capable. This approach is different from how space agencies have traditionally operated. SpaceX's method is more like software development. They release a version, see what bugs it has, and then release an improved version quickly. B13 was like an early version of new software. It worked, but it also revealed unexpected behaviors. Now the engineers can patch the design, they can update their computer models with the new real-world data. This makes the next version of the rocket even more reliable. For people who are not rocket scientists, this is still an exciting story. So what does the tale of Starship B13 mean for all of us in the long run? It means that the dream of going to space is becoming more real every day. For a long time, space travel was something only a few governments could do. SpaceX, with its rapid, iterative approach, has changed the game. The amazing discoveries from B13 show that this new way of doing things works. It leads to faster progress and incredible new insights. It accelerates the timeline for when regular people, not just professional astronauts, might have a chance to travel to space. This is a profound shift in our relationship with the cosmos. The journey to Mars is long and difficult. There are thousands of problems that still need to be solved. How do you protect humans from radiation? How do you grow food on another planet? How do you land 100 tons of cargo safely? The successful flight and surprising analysis of B13 do not solve all these problems, but they solve a few very important ones related to the transportation system. They show that the rocket, the most crucial piece of the puzzle, is on the right track. The unexpected data proves that SpaceX's hardware is even more capable than their own brilliant engineers had predicted. This builds confidence. It shows that the grand vision is achievable. This story inspires a new generation. Young people watching the B13 saga unfold see that engineering is an adventure. They see that science is a process of discovery, full of mystery and excitement. It's not just about numbers on a screen, it's about building giant, powerful machines and learning their secrets. This can encourage more kids to study science, technology, engineering, and math. These are the people who will be needed to design the cities on Mars, to explore the moons of Jupiter, and to take humanity even further into the galaxy. The legacy of B13 is not just in its data, but in the inspiration it provides. In the end, a scorched piece of metal recovered from the sea has told us an incredible story. It told us that our machines can be tougher than we think. It told us that nature still has tricks that our best computers cannot predict. And it told us that the path to making life multiplanetary is being built right now with steel, fire, and data. The wild data from B13 was a gift. It was an unexpected clue from the universe. And it has pushed the dream of seeing human footprints on the red sands of Mars one giant leap closer to reality. For SpaceX and for all of us who look up at the stars and wonder, the future has never looked brighter.